Okay, so important terms to remember from this chapter or the chapter before. I have lever. It's a solid bar that rotates around a pivot and makes it easier to lift a load, move a heavy object, or apply a force. Now the force, it's a push or a pull, and the unit of force is called a Newton, and force equals mass times the acceleration. The work, it's the movement of an object resulting from a force applied to it. Movement is usually in the direction of the force. To calculate the work done, we have to multiply the force by the distance, W equals F times D. And the input force, the effort or force you put into a machine. The output force is the force the machine produces as a result of the input force. Now, the power is the rate at which work is done. Power is measured in watt. Power equals the work over the time. So when you calculate the work, you divide it by the time it took you to do this work, you will get the power. It's the rate at which work is done. The mechanical advantage, MA. Simple machines do not work on their own. Someone has to apply input force to make it do the work. MA is the ratio between the input force and the output force. A mechanical advantage is produced when a simple machine amplifies a small input force to produce a greater output force. Now, the rotation point, the axis or center that a wheel or disc spins. Efficiency, it is the ratio of the output work to input work. The efficiency is output work over input work times 100%. Now, finally, we will see this example. It's a bicycle. It's a compound or complex machine which is made of two or more simple machines. The first part, it's the wheel and the axle as you see in the figure. The second simple machine is another wheel and an axle. The third, it's the pulley. So when we combine these three together, you will get the bicycle, and the bicycle will be able to do the work it does. And over there we have a lever. And that's it. Thank you very much, grade 8.